All right, folks, question number one, right here at the top. Find the molarity of a 47 milliliter solution of ammonium hydroxide if we have 12.1 grams of the solution. First thing you need to do is need to know that ammonium is NH4. It's got a plus by 1, so I'll just put that in there. Hydroxide is an OH minus by 1, therefore the formula is NH4OH. So I'm going to add up a nitrogen, which is around 14, 4 hydrogen, which is around 1, another hydrogen around 1, and an oxygen, which is around 16. I've already done the math on this, and 1 mole is equal to 35.04 grams. And I need that. I'm going to have to use that. Why? Because I'm given grams, and I need to find molarity. So what I am going to do now is this. I'm going to set it up. It doesn't matter the order that you do it in, but it does matter where you put the numbers in the denominator and numerator. So I'm going to take my mass of 12.1 grams. I'm going to put that over the volume of 47 milliliters. Next column. Again, doesn't matter the order of this, but I'm going to next put the molar mass, which I want grams canceled out, so I want to put the 35.04 grams on the bottom, the 1 mole on the top. And then finally, anytime you do a problem like this where you're finding molarity, you need not milliliters, but you need liters. So I'm going to put the 1,000 milliliters on the top, the 1 liter on the bottom. My milliliters do cross out, my grams do cross out. I'm left with liters on the bottom, moles on the top. When I do the math, I should get something around 7.35 moles per liter, otherwise known as big M, molarity. So that is question number one. Question number two, if you have 1.2 molar solution, magnesium phosphate with 15.1 grams, find the volume of the solution. Again, you've got to find the molar mass. And the molar mass of this one's a little trickier. That's why I gave it to you using 2 and 3. Magnesium, we know, is an Mg2 plus, phosphate, PO4, 3 minus. I'm going to need multiples. In order to balance these out, I'm looking at a 6 plus 6 minus, therefore I'm going to need 3 of these. So magnesium, with a little 3 in the bottom, parentheses, phosphate. I need 2 of those, 2 over here. Now, the molar mass of this is pretty big because we've got a lot of magnesiums, we got 2 phosphates, we got 8 oxygens, and 1 mole of this ends up being something around, and again, I did the math on this earlier, 262.86 grams. I'm going to use that. When am I going to use that? Well, it really depends on your setup. It doesn't matter the order, but it does matter if you're putting your numbers in the right spots, numerator, denominator. So I'm going to start with my 15.1 grams. I need to find the volume. So again, I need milliliters on the top when I solve for this. So I have to kind of think about my 1.2. What do I know 1.2 is? 1.2 is 1.2 moles really over 1,000 milliliters or 1 liter. Since I could put 1 liter on the bottom as well. I like just using milliliters. But remember, I can rewrite this so I can have the milliliters on the top, which I'm going to have to do for this problem, with the 1.2 moles on the bottom. It's still the same relationship. So really, I'm going to be using this one right here, just flipping it around, kind of like we do sometimes at molar mass. So I've got 15.1 grams. I'm going to put that one first. I like putting the number that has the 1 on the bottom first. That's just kind of how I like doing things. I'm going to put this now, my molarity of that solution, on the top, 1,000, and the 1.2 moles on the bottom. And you'll see in a second, because of my third column, I'm going to put my molar mass, my 1 mole. Now again, I could have put this in the second column, but I decided not to. I don't know why. 262.86 grams, and now my grams can cancel out. Now my moles can cancel out, and I'm going to be left with a volume. That volume is going to be in milliliters. It could be in liters if you had the 1.2 moles over 1 liter. And when I do the math on that again, I've done it and I need 3 significant digits. So I'm going to say 47.9. The only unit left is milliliters. All right. Next problem says, find the mass of magnesium phosphate. Again, I gave you the same problem because we're going to reuse the molar mass, and we know 1 mole is 262.86 grams. So it says, find the mass of magnesium phosphate. We have 120 milliliters of a 0.9 big M solution. Remember, you almost always have to convert this 0.9 or anything big M into something more usable, and that's moles per 1 liter, or like we're going to do, moles per 1,000 milliliters. So again, how do we start? Again, it depends. I like putting my milliliters first. Why? Because that's going to be over 1, my volume first. Remember, I'm finding mass, so I need grams in the end. So I know in my molar mass, grams are going to be in the end, so that I have to flip this. I can't have grams on the bottom, or it's just not going to work. So I also know 0.9 moles per 1,000 milliliters. I don't have to flip it this time. I can keep it just like this, so the milliliters cancel out, and I have moles on the top. If I have moles on the top, I'm going to take my molar mass, put the 1 mole on the bottom, put the 262.86 grams on the top. I see that milliliters cancel out, my moles should cancel out, and I have grams. Again, done the math, 28.4 grams is how many grams should be in that magnesium phosphate if we have 120 milliliters of a 0.9 big M solution. And finally, number 4. Number 4 says, how much concentrate and water are we going to need to make 150 milliliters of a 1.2, meaning these two go together, 150 milliliters of a 1.2 big M solution with a 5 big M concentrate solution. So I'm telling you, 5 big M is the concentrate. Might as well just say that's M1. This has got to be my M2. And this of A, so it's got to be my V2. So what I'm missing is how much am I pouring in of that concentrate. So I'm going to use the M1 times V1 is equal to M2 times V2. I need V1, so I'm going to divide both sides. Again, I can do this with the numbers. I like doing it with the variables first and then plugging in the numbers. So I know my equation's going to look like this. V1 is equal to my molarity of my second times my volume of the second divided by the molarity of the first. Now I plug in my numbers. I've already kind of indicated what those numbers are going to be based on what the sentence is. So one more time, V1 is equal to molarity of the second. We know it's 1.2 big M. I'm going to multiply that by my volume of 150 milliliters. And then my units are going to cancel out nicely because 5 big M is going to be on the bottom. Why? Because M1 is on the bottom. My M's cancel out. I'm going to need a volume, and it leaves me in the units of volume, milliliters. Do the math on this, and I get an answer that is V1 is equal to 36 milliliters. Again, that's how much concentrate I'm pouring in, 36 milliliters. But I'm making a volume of 150. How much water? Well, that's pretty easy. You take your 150 total milliliters, going to subtract out the concentrate of 36 milliliters, and that leaves me with 114 milliliters of water that I have to add to that concentrate, which is 5 big M. I'm going to pour in 36, 114 together add up to 150. Hopefully this all helps.